Okay, Wildcats. Today we're going to 1. Strike that inverted. Inverses of power functions. Warm up. Determine whether each graph represents a function. Explain your reason. So, I'm going to draw a vertical line through the graph. It only crosses once, so it passes the vertical line test. Okay, let's take a look at 2. Now 2, I draw a vertical line. It crosses twice, and it does not pass the vertical line test. So 1 is a function, and 2 is not a function. And let's take a look at 3. So I draw a vertical line, crosses once, so it passes the vertical line test. So it is a function. All right, go ahead and finish up the warm-up. All right, let's take a look at the next page. Getting started, reflect on it. Consider the polygon drawn on the coordinate plane. Mark out number 1. A. Describe how to show a reflection of the polygon across a line y equals x. I can reflect the points across y equals x. B. Describe the location of the x and y in the reflection. The x and y switch positions. Okay, so go ahead and complete the table. Now this table corresponds to this portion of the graph. So that is this portion of the graph. Okay, go ahead and complete the table. Now, the key for the next table is we're going to switch the x and y. Okay, so -4 becomes -4, -4. -5, -2 becomes -2, -5. -1, 0 becomes 0, -1. -4, 2 becomes 4, -2. 2, 3 becomes 3, 2. 5, 1, 5, 5. All right, go and complete the table. All right, and let's go ahead and graph those points. Okay, so there's that portion of the graph. All right, go ahead and finish it up. All right. Let's take a look at the next page. 1.1, switching x and y. The graphs located at the end of this lesson show that these three power functions, L of x equals x, Q of x equals x squared, C of x equals x cubed. Go and mark out number 1. Number 2, the graph of the linear function L of x equals x models the width of a square as the independent quantity and the height of the square as a dependent quantity. Okay, go ahead and complete the table that corresponds to the graph. A. L of x to transform the graph so that it shows the height as the independent quantity on the horizontal axis and the width as the dependent quantity on the vertical axis. Then sketch the resurfacing graph and label. So we're going to switch the values. So -5 becomes -5, 5. 0, 0 becomes 0, 0. 5, 5 becomes 5, 5. So -5, -5. 0, 0, 5, 5. And then this is now the height, and this is now the width. Okay, go and finish up that graph and table. All right, let's take a look at the next page. B, describe the transformation used to transpose the independent dependent quantities. I switch the independent dependent quantities. C, is the resulting graph a function? Explain the reasoning. The resulting graph is a function because it passes the vertical line test. All right, so we come back over here. I draw a vertical line, crosses only once, so it passes the vertical line test. So this is a function. Okay, let's take a look at the next page. D, compare the graph of L of x equals x to the resulting graph. Interpret both graphs in terms of width and height of a square. The graphs are the same. 3, the graph of the quadratic function Q of x equals x squared models the side length of the square as the independent quantity and the area of the square as a dependent quantity. So here are our table values. These table values correspond to this graph, okay? So here, the next part, we need to switch the x and y values, okay? So this becomes 4, 1, 0, 1, 4, and this becomes -2, -1, 0, 1, 2. So this corresponds to this graph. And then this will correspond to the other graph. Okay, so 4, -2. Oh. Almost made a mistake. So 4, -2. 1, -1. 0, 0. 1, 1, 4, 2. All right, go ahead and finish up the table and graph. All right, let's take a look at the next page. B, describe the transformations you use to transpose the independent dependent quantities. I switch the independent dependent quantities. C. Is the resulting graph a function? Explain your reasoning. The resulting graph is not a function because it does not pass the vertical line test. So we come back over here. I draw a vertical line, crosses once, twice, does not pass the vertical line test. So, not a function. All right, go ahead and finish it up. All right, let's take a look at the next page. Go ahead and mark out D. 4. The graph of the cubic function c of x equals x cubed models the side length of a cube as an independent quantity and the volume of the cube as a dependent quantity. A. C of x to transform the graph so that it shows a volume as an independent quantity on the horizontal axis and the side length as a dependent quantity on the vertical axis. Then sketch the resulting graph and label the axis. Okay, so this table corresponds to this graph. Now, the transformation, we switch the x and y values. So this is -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Okay, so we're going to graph these points. So -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. So this corresponds to this graph. B. Describe the transformation used to transpose the independent and dependent quantities. I switch the independent and dependent quantities. C. The resulting graph, a function, explain your reasoning. The resulting graph is a function because it passes the vertical line test. So, I draw a vertical line. It crosses only once, so it passes the vertical line test. So this is a function. Okay, go ahead and finish up that page, mark out D, and let's take a look at the next page. 1.2, inverse the power functions. By transforming the graphs you traced in the previous activity, you were able to see and sketch the inverse of the functions L of x equals x, Q of x equals x squared, and C of x equals x cubed. Go ahead and mark out this portion. Number 1, use your trace graphs to verify strategy. All right, go ahead and finish up 1. All right, let's take a look at the next page. Go ahead and mark out this page. Go ahead and mark out this page. You can keep this page if you'd like. And then let's take a look at here. The student works 1A, 1B, 1C, 2A, 2B, and 2C. And then mark out number 3. And then mark out this page. Go ahead and start working on your assignment and have a wonderful Wildcat day.